Recording? Good. All right, here we go. Ah, yes, bell curves. Soon, my friends. It's good stuff. All right, program this bill. Okay, we got to know what we're testing. X. What is X in this experiment? Love it! Number of times he gets them on the correct feet. Thank you, Linda. Number of times he gets them on the correct feet. What's the least?
0.
He might never. He might never. Now remember, I have a data point. He got them correct once. But theoretically, if I want the whole distribution of what can happen, 0 is the small. What's the big?
10.
10. Beautiful. Definitely binomial. We've already established it's binomial. Love that too. The chance of getting him on the correct feet? 0.5 if he's guessing. Okay, it's done. Now at this point, have we looked at dist draw in here? This is a good one to look at for in dist draw. At this point, go to program, dist draw, which is number 2, and take a look at it. And there he is. What's he look like? Go ahead, be brave. What's it look like? It's like a bell curve, and it should be. It's symmetric. What sucks about this is it's the TI, and nothing's labeled. Nothing's labeled, which is unfortunate. So what I'm going to do is get it in focus first. That's a little better. So what you've got here on the bottom is number of times, as Linda said, on the correct feet. Zero's over here. Here's 1. Hopefully you're seeing this. That's 5. That's the mode. That should happen on average. And then you got 10 way over here. You got 9 backed off a little bit. What's here? What's on this axis? Why is this so high? Why is this so low?
Because isn't the probability of that?
Yes, it's exactly what it is, Johnny. You're seeing the probability of that number of times on the correct feet. Thank you. You're seeing, remember what the distribution is an XP of X column. XP of X. You're seeing XP of X. It's a graphical form. A distribution versus a histogram. So this is a P of X column, a probability of that. Now, it's Excel, so it sucks. That's why I got so excited, Sandra, when you showed me the graph you drew, which was awesome. Because yours was labeled with axes, right?
Yeah.
So what kind of sucks about this is there are no axes. Now you could make axes on your screen if you want by simply tracing, and then you could scroll around. So right there, that probability is about 25%. That's the highest probability. So that's why, I got so excited, Sandra, when you said, I said, what's the average number of times you should give him the correct feet? You said about 5. 25% of the time, he should get them right 5 times and wrong 5 times. Right. So in other words, if I watch a bunch of kids his age put shoes on their feet, 10 at a time, 25% of the time, so in 25% of those observed studies, you're going to see it 5 and 5. Does that make sense? Now, what's cool about this is, roughly 21% of the time, 20.5% of the time, you're going to see 4 and 6. You're going to see him get it right 4 times. That's still pretty high, isn't it? That's the same probability as getting him right 6 times and wrong 4 times. And hopefully that makes sense. The reason this is a perfect bell curve is it's perfectly symmetric. Right and wrong have the same probability. The chicken distribution was totally lopsided because it was 90-10. So right now, 21% of the time is 4 and 6, 25% of the time is 5 and 5, and 21 additional percent of the time is 6 and 4. That's a lot of the results, isn't it? 21, 20, 25. That's 67% of the time, 2/3 of the time. They get between, hot damn, 2/3 of the time. That sounds like another number we know, doesn't it? That sounds like another number we know, doesn't it? 67%, it's pretty close, 68%. So now the question is, where's unusual on this curve? How many times would Max have to get his shoes on the correct feet for you to say, I don't think he belongs on this curve anymore? Is this unusual? No. That's 3 and 7, right?
Right.
Why is that not unusual, friends?
It's with second deviation.
Oh, okay, you're going with deviation. I was just going, it happens too much. But I like what you're saying too. So the thing is, I don't know what the deviation is just yet. I did a quick little calculation over there, but I wouldn't trust that. I wouldn't trust that one too much. The likelihood of that is almost 12%.
Yeah.
Okay, so this, I'm not so sure this is unusual. How about this one?
Yeah.
Okay, so here, Unusual. You're calling that unusual.
Yeah.
Got it. No problem with that. So if this is not unusual, this isn't either, correct?
Correct.
So you're saying this must therefore be.
Yeah.
So you guys have now put lines in the sand for us, haven't you?
Mm-hmm.
You've put lines in the sand. I'm gonna hit graph again. So you have said that 2 and left is unusual, and that 8 and right would be unusual. So from what I understand, make sure I'm interpreting your results correctly. If he landed in here, you'd think he was guessing. Is that correct?
Yeah.
If he lands in here, you think he's guessing.
Yeah.
Because he's getting it so close to 50-50. And that's the thing. I put it in quotes because we haven't really defined what close is just yet. Although you've told me these happen enough, or they're within enough deviations to be like, oh, that's close enough to call it acceptable range of error. If he's down here, I don't think he's guessing. And if he's up here, I don't think he's guessing. So that's what I'm hearing from you guys too. Johnny, what's on your mind? Go ahead.
No, I mean, that's a relative statement.
It is, isn't it? It is. And that's why. And this class is full of gray, isn't it?
Yeah.
This class is full of gray. What I'm trying to do is measure the gray in some way. So as soon as this thing popped up as a bell curve, did any numbers pop into your guys' heads? As soon as you see a bell curve, you get percentages for free, remember?
You know, the
You get the quartiles, you get the standard deviations, 1, 2, and 3.
My visual went to quartile.
Exactly! Your visuals go to these little cutoffs that we've established. So Johnny, I'm not saying, you might say to yourself, what the hell, he got him on 1 out of 9. He's still guessing, he just guessed really poorly that time. I got no problem with that. My comeback with that would be, what's the chance of him only getting it right 1 out of 9 times? And that's where this distribution really comes in handy, because the chance of that happening is less than 1%. That makes me think that's an outlier, which means it's not on the guessing curve. So here's, John, if I may go 244 on you for 30 seconds, if I may. Because Max landed so far left of the middle of this curve, I think Max is on this curve.
Oh, right, exactly. Huh?
Does this make sense? I think he's guessing, quote unquote, on another curve. And when I say guessing, quote unquote, on another curve, I don't think he's guessing. I think it was Linda said it, maybe it was you that said it, I think he thinks that's right. He puts the shoes on those feet, and whenever I hear parents say, my kids did it too, it gives me more data. I think at some point in time, the shoes go on those feet, and that looks right to them. Now, I can't explain the one time where he got it right. I can't explain that. Maybe he was drunk that day. But the other 9 times he got it wrong. Here, please.
I was going to say, what I've seen mine do is they line up that flat side of their foot with the flat side of their foot.
Dude!
Thinking that, oh, okay, that's right.
So maybe it's the construction of the shoe that does it.
Like,
That's a fun test. Build 2 kinds of Crocs.
I've just watched him do it, like, okay.
Oh, that's cool. So you're much more cautious observer. We need to build 2 kinds of Crocs. Build a Croc that fits on your feet correctly, but the edges are switched.
Right.
Would they do that for us?
As soon as she said that, I remembered that.
That's badass.
As soon as you said that.
We should write a letter to the Crocs company and see if they'd switch a mold for us to build those shoes.
It's for children.
For kids. It's for the kids. It's for the kids. How can they say no, Eric? I love that.
I remember thinking when I was little that I didn't like the way it looked with things curving in, and I was like, I like the way it looks when they
I
go
think that probably has something to agree. You guys are so much better statistics than I am. Rachel.
I know my Crocs are pretty wide.
Yeah, at the top part or the bottom, the whole thing.
Sometimes I might actually look at them more carefully because I can't tell. Because
Yes.
when my feet are in there, it's so spacious.
Gotcha.
So I'm wondering did he ever do that with tennis shoes? Or Velcro?
That summer, he never wore anything except his Crocs or went barefoot. So it was hard to, and remember, I wasn't watching him as he put them on because I was trying not to let on that I was watching him.
Yeah.
So I lost a bunch of data that of course would now be very handy to have. Ha! So,
Just have another child.
We have a professional comedian in the crowd today. Thank you. She's here all week. Didn't raise the waitresses. Well done, sister. Well done. Never say that. Shoot, I had a thought that's gone, and that was brilliant. That was brilliant. I have another kid just to analyze some data. Oh, trust me, he's only 7. I got years left. I got years left.
Sean,
Please.
The more you have, the duller your
The waterier it gets?
The jollier.
The jollier?
Jollier.
It's like Santa Claus to you?
Easier.
Oh! The easy. I failed to see how having more children could be easier.
It is. It's amazing. It's
That's mathematically impossible.
yeah. Don't try to figure it out.
I know what you mean is the second one is easier than the first one, but it's still more than one.
Yeah, by the time you get to
Define easy a little bit different than I do, my friend.
I don't care anymore.
They distract you.
I think you're all insane. No, I'm kidding. I love every one of you. I love every one of you. Let's stop talking about this. It's making me sick. No, I'm going to barely survive this one. Now, I do have a theory, though, and it has nothing to do with the shoe's shape. So Max, I think, is down here. But this, although that red curve looks like a wrong curve, in his mind, that's right. Now, he's obviously going to be over here, because now he always gets his shoes on the correct. What I would love to test, and I can't test this because the time has passed, does this curve smoothly transition over to here? Like, at some point, is he guessing? Oh, Linda, you've heard this before, maybe. Go ahead.
No, just finish your thought.
No, that's unfinished. Like, is there some point, for a brief period of time maybe, where he is guessing until he gets to this point? Go ahead, you finish your thought. Go ahead.
Well, I just keep wishing there were more than 10 trials because I wonder if he would have been closer to the average and just
And I just randomly got some noisy data. Back to Johnny's point, right?
The problem with more trials, though, is that, like, for a 2-year-old or a 3-year-old, whatever he was, he is learning so quickly, and so you don't know how much they're observing from day to day.
And there's a couple reasons why I use 10. First of all, 10 is an easy number to multiply by a half. I could have used 20. Nothing wrong with 20. 20 would have been nothing. Anything more than that, I'm not doing a random sample anymore. I'm actually checking every single day. Every time I watch him, I'm not the best researcher. I can design a great research study, I'm not the best at carrying it out. Every time I watch him, I'm going to screw up something somewhere, right? I'm kind of a loud dude, as you noticed, right? Like, why is Daddy carrying around a clipboard all the time? Is he that much of a geek? And he's 2, he's pretty perceptive, right? So the idea then becomes 10 was a nice small number to get the point across. I'm not saying I would publish these findings. But it does create noise, and that's why I can't address Johnny's claim that, well, it's all relative. It is definitely very relative, right? It's very, very relative. The other trick is, if I watch him over too long a period of time, there's another variable that creeps in, and the variable is learning. One of my students in the other class asked, have you ever asked Max why he started putting his Crocs on the correct feet? And I never had. It was so funny. 7 years have gone by and I never had. So I went and asked him last week at some point after the other class did this experiment. I said, Max, so do you remember when you used to put your Crocs on the wrong feet? He's like, kinda. And I showed him the pictures, like, oh yeah, I remember that. You gotta kind of chuckle out of it. I'm like, little old man, you know. I'm like, so why did you start doing it correctly? He's like, well, I just watched you and Mommy. And I said, how interesting is that? He wasn't watching us originally. He was just doing whatever seemed correct. But then his frame of reference got wider and he began to take in other stuff, roughly commensurate with going to school and having other kids in his world. The world's just not him anymore. Now the world has other people in it. And it's just so interesting. But I don't want that to mess up whatever I'm observing. Not to mess up in a bad way, but to mess up in a statistical way. That confounds the variables, right? Exactly, it becomes dependent versus independent. Thank you. So it was a fun experiment. And yes, more than 10 trials, of course, we're going for publication. I mean, Gallup calls 10 people and makes a conclusion. Good luck keeping that job. But for the sake of illustration, for us, I think it's just fine. Good. Makes sense? So the big idea is, how can you identify binomials? And I think we've done enough data sets now. I think you got a pretty good indicator of it. I'll have another one for next week for you too, just for more practice. And on the last exam, the chicken problem is definitely binomial. The one about chickens and salmonella, that's definitely binomial. So just so you know, I mean, I don't want to pull anything over your eyes. Just so you know, that's when you get in there and crack that open, and you'll know it is. Either the chicken has it or it doesn't. I mean, it's pretty straight up. So, cool.
Yeah.
All right, let's take 5. I took you 5 over. I apologize. But that's okay. I think we got some good stuff done here today.